Over the next few episodes, we are going to build a parcel locker system. Not a toy example, not a blog post CRUD, a real domain. Packages, lockers, assignments, pickups, returns, modeled the way a senior developer would model it before writing a single line of Spring Boot code. By the end of this series, you will have built something you can actually show in a job interview and say, "This is how I think about the domain problems." Let us start with why we choose this domain. Most domain-driven design tutorials use a bank account as an example. It is clean, everyone understands it, and it teaches nothing about the real problems you will face. We choose a parcel locker system for 3 reasons. First, everyone understands the business. You don't need to explain what a package is, what a locker is, or what delivered means. We can spend 100% of the time on the architecture instead of explaining the domain. Second, the domain is rich enough to actually need domain driver design. A parcel locker isn't crude. A package has a life cycle, it has rules. You can't assign a package to a locker that is too small. You can't pick it without a code. These are business invariants that need to live somewhere in your code. Third, it maps directly to what you build at work. Packages are orders, lockers are warehouse, assignment is inventory allocation. If you can model this domain, you can model any domain. Here is everything we are building, not code concepts. Package is our first aggregate root. It handles the full life cycle of a parcel, from the moment it is registered to the moment it is picked up or returned, and it enforces the rules. A package cannot change its destination after being registered. It cannot be assigned to 2 lockers simultaneously. The package aggregate root is responsible for enforcing these variants. Locker is our second aggregate root. It represents a physical locker cabinet. It knows its own size, small, medium, large, and enforces one critical invariant. It cannot be occupied by 2 parcels at the same time. 1 locker, 1 parcel, 1 transaction. That rule at the bottom, the only entry point, all modifications go through the root. 1 aggregate equals 1 transaction. Is worth remembering. We will come back to it every time we add a new aggregate to the system. Let us look at how the system is structured. We have 4 modules: orders, parcels, lockers, and party. One single deployable jar, but each module has clear boundaries. They don't call each other directly. They communicate through a shared event bus. When a parcel is registered, the parcels module publishes a parcel registered event. The orders module reacts to it and updates the order status. Neither module imports a class from the other. That is the rule. The database is also per module. Separate schemas, parcels, lockers, orders, party. No module queries another module's tables directly. Here is how our project structure looks. Every module follows the same hexagonal structure. Domain at the center. Ports as interfaces, adapters at the edges. The domain folder has 0 Spring annotation, 0 JPA, pure Java. These rules on the right, this is the contract. If you open any module in this codebase and it follows these rules, you know exactly where everything is. Now, why not microservices? Orders, parcels, lockers, and party don't work without each other. Splitting them into separate services from day one means distributed transaction, network overhead, and operational complexity with zero benefit at this stage. Modular monolith gives us one deployable artifact with enforced module boundaries, and if one module grows and needs independent scaling later, the bounded contexts are already drawn. Extracting it as a microservice is straightforward because the boundaries are already there. An architect doesn't just decide what to build, they documented why. The decision stays in the README. Here is the full roadmap. Episode 1. This is the map. Episode 2, value objects, how to make invalid states impossible at the type level. Episode 3, aggregate root, package and locker with real business invariants. Episode 4, repository, domain language, not JPA language. Episode 5, domain service, locker assignment, logic that doesn't belong to one aggregate. Episode 6, domain events, decoupling the domain from the side effects. Episode 7, CQRS, separating the write model from the read model. Episode 8, bounded to context, drawing the route boundaries. Episode 9, the full application, everything assembled live. 2-3 hours from empty project to running system. One series, one application, built piece by piece so you understand every decision. Episode 2, value objects. We will start with package size and I will show you a real bug that happened in a production parcel locker system because weight and width were both double. The compiler could have catch it, it didn't. Source code on GitLab, link in the description. Subscribe so you don't miss episode 2. See you next time.